Hello, this is Kevin Trainer, and welcome to part two of my lecture for chapter 9 of Murach's third edition MySQL book. And in part two, we're going to go over the new material, which is new to the third edition. And that's because it's new to MySQL 8, which is pretty new as well. So the first group of things we're going to cover are the regular expression version of these functions to manipulate string values, to test and manipulate string values. And these are, in a lot of ways, a replacement for the functions that we did for strings back in part one. Uh, but I think the positive thing is that they're based on regular expressions, which are a really powerful tool. And they're just increasingly the popular way to do things in tools that have introduced them. So we're going to learn about the inster, the subster, and the replace. So let's go do that. All of these are going to be based on patterns which are typical um, regular expression patterns. The ones that they show here, the circumflex or the caret says the pattern has to match from the beginning of the string. The dollar sign, it has to match all the way to the end. A period matches any single character. A character list that's in square brackets is one character that can be any of the characters that appear between the brackets. Um, you can do the same thing with square brackets and a range. It can be any of the characters in that range of characters in the collating sequence. You can use this vertical bar, which I call the OR bar, to say that the string can match either the expression on the left in the pattern or the expression on the right. We can have a character with an asterisk after it that says that we want 0 or more occurrences of that character. Finally, we can have a character list, which is a sequence of characters, and we put them into parens, and we can say we want 0 or more of that sequence. Okay, and there are certainly other meta characters in regular expressions that are supported here. This is just um, an introductory list. Okay, so here are some examples. When we're using the like version, we're looking for a match and we're expecting to get back true or false expressed as 1 for true and 0 for false. So if the first argument is the string that we're matching to, or it could be a column name, um, or some expression that resolves to a string, and if we're matching 1, 2, 3, well, certainly 1, 2, 3 is a substring of ABC 1, 2, 3. We get a 1 for true. In the second one, we're putting the circumflex or caret in the beginning, and we're saying we want to match 1, 2, 3 in positions 1, 2, and 3, and that's false. So we get back a 0. The next one we have is this kind of inster version, which is going to give it the index of where it matches in the string. So here we're trying to match the character string 1, 2, 3 anywhere in the string. And where does it start to match? Well, it starts to match here at character 4, so we get back a 4. The substring version uh, we're trying to match and extract a substring. Okay, so again, we're matching ABC 1, 2, 3, and we're saying that we want one character from this range of characters, and then we want three uh, of the digits 0 through 9, and we want them to match to the end of the string. So what matches? Well, C, 1, 2, 3. It's this substring right here. And the very last one, we're trying to do a replace. So we're saying again, we've got our ABC 1, 2, 3 as the string that we're processing. We're looking for a character 1 or 2, and we want to replace either of those with the 3. So we replace the 1 and the 2, and we get ABC 333. Okay, so those are the general principles at work. Here are some examples. So here's the case where we just want to list the cities that have the cities in our vendor database where the vendor city has a space in it. So you'll notice that the where says that the index of the space in the vendor city is greater than 0. So if there's no space, it's going to be 0. We're not going to select that row for our result set. Otherwise, we're going to return the index of the space. And that's what we've got. Okay. The next one, we're looking to extract a substring. Okay, so again, let's look at the where. What rows are we going to get? Where we're going to get the rows where the substring at the beginning of matching SAN or LOS is not equal to null. So if it's not there, well, then the result for that row is going to be null. So we don't want that row. Okay, and then what's the value that we want to bring back? Well, we want to bring back the substring that matches either SAN or loss, and so we can see that we get loss and SANs. Here we're using a replace and a like, so it's kind of nice that we've used the where clause here to only show the rows that really count. So we're saying to pick the rows, we want a row that matches regex like, where there's somewhere in address 1 there's street. Okay, and what do we want to do? Well, we want to replace street with ST, and as you can see, we did it in a bunch of rows, even though the type here says that there are only 4 rows. You can see we're showing many more than 4 rows already, so I think this was a mistake on the slide. Okay. All right, let's go look at some of the ranking functions. I like these. These are pretty neat. We can do the row number, we can do the rank, we can do the dense rank, and we can do the entile. They're all pretty useful in my estimation, so I'm happy to have them here. So let's go explore them. So the row number, okay? A question I get often when I do a query is how many of these things did I get back? Okay, I can usually look down the bottom at the in MySQL Workbench. I can usually look down at the console output and see, I got 8 rows, I got 12 rows, I got 7 rows. But if I just wanted to say, well, what was the seventh one that I got? I couldn't easily do that. Well, this row number gives us the opportunity to do this. This is the row number in the results set uh, after it's been ordered, after order by. Okay, so this is just a line number for the output. Very convenient and helpful. What? Oh, I'm sorry. I didn't mean to do that. What if we say that we want the row number and we're going to say over a partition by vendor state, order by vendor name. Okay, well, here's what happens is that we are partitioning this by vendor state. So you'll see that the row numbers 1 and 2 are within, 1, 2, and 3 are within the state Arizona. But then we go to the state California, we start all over again with 1, 2, 3. So again, that helps us if we're trying to answer the question, gee, how many vendors do we have in each state? We can do a query like this, but instead of having to count them up by hand from looking at the query, we can just look at the row numbers, which is pretty helpful. Now, we've got this thing called dense rank. Well, we've got rank and dense rank, and they're pretty interesting, but they serve the same purpose and are slightly different. Rank, I like to think of this as the kind of place that you would give to a finisher in a foot race. Okay, so here you see that the first 3 rows all got the invoice total 6, so they're tied for first place. So we give them 1, 1, and 1. Okay, in a foot race, if 3 people tie for first place, the next person who comes in is in 4th place. Okay. Now, if there are 2 people tied for 4th place, then the next person who comes in is in 6th place. Okay, and in fact, if we look at this is a little bit easier to see if we take this and we actually run this. So I'm just going to pull over my is this in AP? Yeah, this is in AP. So let's plug that in. Let's tell it that we're using AP and give it a run. And you'll see that, so we've got, there are 114 invoices, but the rank's going to go down to 114. So the final finisher is all by themselves, so they actually get 114th place. Where, as you can see, on the dense rank, which we're going to see in a minute, only goes to 106. So how does the dense rank work? Well, in the dense rank, we're just looking for how many ranges of values we have. So the top range is 6, so that gets 1. The next range of values is 9.95, that gets 2. The next is 10, that gets 1, 2, 3. The next is 50, there's only 1, that gets 5. Oh, well, I'm sorry, the next one was 4, the next one was 5, so we go up like that. So, not the way that we number the finishers in a foot race, but there are times when we say, well, what kind of values do we get? We can say, well, our top value was 6, our second value was 9.95, our third value was 10.0. I can see that the some analyses, that's exactly what you want. So you've got to either do rank for the foot race version or dense rank, which is maybe more business analytical version. Okay, so those are both, I think, very helpful. Glad to have them aboard and things that we can use. Um, Entile. Okay, what's entile? Well, we're taking our population and we're dividing it up into groups, and we're not always going to divide it up with the same number of groups. And so then the question is, what, how many groups are there going to be? Okay. And if this were percentile, there'd be 100 groups. Okay. Here, uh, in the first one, we're only having two. So if we have two groups and we take these terms descriptions, well, we've got a total of five. So we've got three in the first group, two in the second. If there are going to be three groups, we've got two in the first, two in the second, one in the third. If we're going to have four groups, we have two in the first, one in the second, one in the third, one in the fourth. Okay, so this is just a way to put things into groups um, of a different number of groups. All right. Now we've got some even fancier analytical things to do. We've got a couple more left. As you can see, there are a lot of opportunities here. I'm going to leave those for you to read on your own. And then I'm going to go down, and first of all, I want to point out that we're using two tables in a database I don't think we've even used yet. It's the EX database. EX stands for examples. Okay, so it just has a lot of odds and ends in it. And two tables that we're going to use are the sales reps table and the sales totals table. And the sales rep, there's a rep ID, a first name, a last name. In the sales totals column, it has the sales totals by rep by year. So we have the rep ID, the sales year, the sales total. Okay, so how could we use this? Well, here's what we could do. First of all, let's just get a look at that database. Okay, so we're going to come over here to Workbench. I'm going to close off the thing that we just saw. I'm going to say that we're in the EX database. Sorry, EX. And the tables, we've got sales reps. So let's just look at what's in sales reps. So we've got 5 sales reps. Rep ID 1 through 5, Jonathan Thomas, down through Lydia Kramer. Okay, and then next, let's look at sales totals. Okay, and we have rep ID and year, so we don't have the same number of reps by year, but this is really sophisticated enough to figure that out. And sales figures go up and down per rep. Okay. All right. So let's look at the first query that we're doing. Let's look at the answer first. Okay. What are we trying to answer? Okay. So the sales year, the rep name, how much they sold, and then we're going to list the name of the highest person for that year, the second highest, and the lowest. Okay? So Jonathan Thomas in 2016 was the highest, so that's him. When you look at Andrew, you can see that he's lower, and you know that Andrew is, he's not the highest, he's not the second, he's not the lowest. Uh, I'm sorry, he is the second. There are only three. He can only be in one place. Okay, and then Sonia, she's not the highest, she's not the second, she is the lowest. And if you just look at the values for highest, second highest, and lowest for a particular year, they all have the same value. Now, is this a well-designed report? Well, it's a little busy by my standards, but it gets the job done. Okay. And one of the interesting things is it works uh, with kind of any number of reps per year. Okay, so it's pretty general, right? And let's just take that query and take a look at it. So we got the sales year. We're going to reassemble the rep name. We've got their sales total. And then we've got three columns: first value, nth value, last value. So provided that we order them the right way, the first value is going to be the largest because we're ordering by sales total descending. The nth value that we're asking for the second one, okay, by sales total descending. And the last value by sales total descending is going to be the lowest one. So we call these highest sales, second highest sales, and lowest sales. And as exciting as all that is, let's see that run. I always like to do that. So let's just pull over Workbench, get a new editor panel, put that in, and give it a run. And there it is. Pretty nice. Again, sort of busy, but it gets the job done. Okay, what's next? The lag function. Okay, now um, it's pretty easy to do this kind of processing on a spreadsheet. Okay, when you want to compare the row that you're on to the prior one, provided that it was a row for the same individual. Okay, so what are we doing here? Well, we're looking at the reps, 1, 2, 3. Let's do this one. Let's run this, okay? Because we're not looking at all of the output here. So let's come back, go over to my SQL Workbench, get a new editor panel, and run this. Okay, so now you can see we have all the reps here, and we have all their years. Okay, and so let's see. I think it would have been nicer to put in the name. Okay, the rep name. Okay, here we just have the rep ID. How could we have put in the rep name? Well, we could have joined. From sales totals, join sales reps, and then we could have reassembled the name up here at the top right after the rep ID. Wouldn't that have been a more useful report? Okay, but if you look at the three rows for sales rep 1, okay, we've got the current sales. That's for the current year. Then we show the last sales. That's for the row before. Okay. And we've specified, here's where we use the lag. Okay, we go back one row. So we're lagging a 1, and then we're telling it if this is the first one, then just put a 0 in there. And then we're using a combination of these two, the current sales column and the last sales formula to create a formula for the change. Okay? And if you go through the math, you can see that the change is appropriate per year, per rep, all the way through. Okay, and then how did we get that to happen? Well, let's just look. So with the rep ID, the sales year, the sales total, and then so the sales total is current sales. Now we have a lag. We're getting the last sales. So we're lagging one row. Okay. If we don't have a row to go back to, we want the value 0 over partition by blah blah as last sales. Okay, and then the last one we have to calculate the lag all over again because we can't use the value from that column alias yet, unfortunately. And then the value of that is called the change. And that's how we get what we get. And I think that's very powerful. That's without this kind of lag capability, this is the kind of thing that really weren't able to do in MySQL, at least, before the advent of these kinds of capabilities. And it's nice to have it. It's something historically I've done with spreadsheets a lot, but haven't been able to do it with MySQL. And I'm happy to have the capability here. And here's one that's kind of interesting. So we have two functions. One is percent rank, and the other one is cum distribution, which is cumulative distribution. So we're getting percent rank. So in 2016, we've got 3 reps here. The rep that's the highest is has a value 1. That's 100%. The rep who's in the middle gets 0.5, and then the rep who's at the bottom gets percent rank 0. Those seem kind of rough to me. I'd like this cumulative distribution. So we've got the person at the bottom at 1/3, the person in the middle at 2/3, and the person at the top at 100%. So that's kind of attractive to me. Okay, and how did we do it? Well, we asked for the percent rank, and then we gave it the partition. Then we asked for the cum dist, and then we gave it the partition, and that's how we got what we want. And again, I think this is pretty promising. The hard thing to do in plain old MySQL is to do these analyses that required more than one row. Okay, it can be done, right? You can do it by creating summary views and then joining them. Okay, so I mean there are ways to do it, but this is a pretty easy way to do it, and it's kind of nice to have this functionality. So that is it for the chapter. That's it for part 2. That's all the new version 8 functionality that we wanted to talk about. So I'm going to say bye until next time. Bye-bye.